Alright, y'all, here's an explanation of that problem. You got this house that's a meter from the street, and from that location, 2 meters to the right to the power station. So you want to figure out, how do you lay the cable? Well, if the distances through the property and the distances along the street cost the same, well, then you would want to do the hypotenuse, which would be the shortest distance. But this distance through the property, that costs twice as much. Alright, so there's a 2-to-1 ratio. So right now, if we just assume $2 and $1, which wouldn't make that much of a difference, 200 and 100, because it's still a 2-to-1 ratio. Alright, so this would be $2 and that would be $2, so right now we'd be spending $4 or $40 or $400 or $4 million, depending on what the ratio 2-to-1 refers to. Okay, so what we got to do is figure out where should we put that point, because there's going to be some range of distances. Is it the hypotenuse of the right triangle with legs 1 and 2? Is that the distance? Or is it somewhere in this region? Well, let's speculate it's somewhere in that region. And so we'll call this x, and we'll call this 2 minus x. And so we got two distances. We got the distance of this right triangle plus the distance 2 minus x. The 2 minus x, it costs half as much per meter as the distance through the property on the hypotenuse of this right triangle, with x and 1 as the legs. Okay, so if you use the Pythagorean theorem, that is going to be 1 plus x squared. Okay, so these are the two distances. The root of 1 plus x squared and 2 minus x. And the root of 1 plus x squared costs twice as much. So I'm going to multiply this one by 2 and add it to that to get the cost function. Okay, and so the goal is to minimize that, and this is where we got to get the graphing calculator. Okay, and so you can see I put in the y equals that cost function, and now the window setting that I set up for this between 10 and negative 10, and I got as high as 30, because this has got to be a positive number. You know, how the heck are you going to add two numbers and get a negative? So here's the graph. And so if you notice, right after the y-axis, just a hair after the y-axis, is where this thing starts to come back up. So there's some minimum value right around there. All right, so let's narrow the window. Let's see where that is. So we know it's after 0. So let's go to 4. It's definitely not 4, because we already did 1 plus 2, right? Okay, so now let's check the graph now. So somewhere after 0 and up to 2 has got to be our range. So what do? We go to the table set, our friend the table set, and we set this to 0, and I'm just going to go by 0.1s. So now we'll go to the table and we see what happens. So I'm trying to get you guys to see this. Oh, notice somewhere around 0.4 and 0.5. All right. So we're going to start at 0.4. And go by 0.01. Now, I already know what the answer is because I did this earlier, but we'll scroll down and you'll see right about there. So notice somewhere around 5.57. That's the answer. Now there's an actual way we can solve this using calculus. Now this is not something you guys got taught to do because this is a little more involved. I'm changing it to the exponential and I'm just rearranging the function. Alright, I'm going to show you how to do this using derivatives. So remember when we got our graph here, it did this, and so somewhere around here. Where's that located? And so we found that that was about 0.57. And so when we have the slope of the tangent line equal to 0, that means the derivative equals 0, that's going to be that point. Right now we've kind of estimated that's about 0.57. Alright, so you take the derivative of this thing, put it equal to 0. Alright, so multiply the 1/2 to the 2. Subtract 1 from the exponent. Oh, I forgot to put the x squared here. Alright, so that's negative 1/2. Now because what's in the parentheses is not x, we also got to take the derivative of that and multiply it. So the derivative is 2x. And then linear term, negative 1, and then a constant term. So that's that thing. Alright, so that's 1. This is going to be on top of the fraction, and since this is negative, that's going to be on bottom. And that's what that, and this equals 0. Alright, so basically this has to be 1, so you guys can rearrange this. But this is what we would now solve. Alright, so square both sides. Subtract. Oh, look familiar? So x is the square root of 3 over 3. Which is, if we go back to our friend the calculator, and we turn it on, and we do the square root of 3 divided by 3, we get, look at that, 0.57735. Okay, y'all take care.